So this is lesson 1-2. It's entitled Attaching Numbers to Position and Time. So we're taking some of the things from the last lesson and we're going to put numbers on them. We have a phrase for that. We use the word quantitative when we're talking about studying things with numbers, and we use the word qualitative if we're dealing with just sizes and scales but not specific numbers to determine those things. Like a qualitative description, qualitative would mean something like saying it's big or it's large or that something is small, but not actually telling you numerically how big or how small. Where quantitative is describing that with actual numbers, saying that the distance is 18 miles. You're actually putting a number to the distance, or the volume of that fluid is 13 milliliters. And you can remember them too. I mean, if you take a look at the beginnings of these words, quantitative, quant like a quantity, an actual number, and then a qualitative, and I assume qualitative is qualifier or something like that, but quantity with numbers. So I have here an origin, and the origin is right here on this coordinate axis. Right? A coordinate axis is almost like a ruler that you can place down in space. And I have numbers on here, so this is quantitative, and I'm saying that each one of these numbers is telling me a position in meters. Right? And the 0 is called the origin. And we need a 0 so that we have some sort of reference to tell where these different positions are located. So that if this spot is 0, then over here is the position of 1 meter. And again, we're dealing with straight line motion here. So this is a coordinate axis that talks about one dimension, left or right on this page. It really doesn't tell you anything about how far up and down on the page an object might be moving or might be positioned. It just tells you left and right. So here's a motion diagram, and you saw these in the last video. We're going to define some more attributes. One of the attributes we're going to take a look at is a quantity called distance. Distance is defined as the path length between two positions. And you see it on one of these motion diagrams by looking at the space between the dots. The distance between two dots is shown by this gap from here to here. So if these dots were further apart, we'd say that you're looking at a greater distance. For instance, the distance from here to here is shown by this path length, but the distance between these dots is further. And the distance this object traveled keeps getting greater for every unit of time. Now time, the idea of time is a little more difficult to define. It's actually in modern physics a very complicated thing, where in modern physics the concept of time is closely related to the concept of space, and that, as you may have heard, as you travel faster through space, that time actually slows down. You travel slower through time. But we're dealing with a very classical definition of time, and something that you could probably relate to. We're just going to say it's when an event happens is measured by a clock. So time is a thing measured by a clock or a stopwatch. So in the next slide here, I took this very same motion diagram from the previous slide, and I've laid it on top of this axis system. So we've taken a motion diagram which in the previous slide was qualitative. There are no numbers on this picture at all. Right? It gives you a sense of distance because you have a picture of the dots being spaced far apart. It gives you a sense of time because every time I draw a new dot, a certain amount of time has clicked off a clock or a stopwatch. But in the next slide, I'm actually attaching numbers to this. I'm doing it in two ways. First, I'm labeling each dot with a specific time. Here, time is 0. Here, time is 7, and let's do this in seconds. And pardon my handwriting. So we'll measure time in a very standard unit in physics, which is the second, and you've seen that measured on the clock in second hands. So every time I draw a new dot, 1 second will have gone by. So if this is time 0, This is the location of the object at 1 second, 2 seconds, 3 seconds, 4 seconds, 5, 6, and then finally 7 seconds. The other way in which we're quantifying things is on this axis system we have the position in meters. The origin has been placed here, so the very first dot represents the initial position of the object. So the initial position is -8 meters. The negative sign just means it's to the left or to the other side of the origin. And then different positions occur at different times. For instance, at 1 second, the object is now at a position of -6. At 2 seconds, the object is at a position of -4. So we're going to use the letter X to represent position. So you can see over here, x0. That means the position at time 0 is -8 meters. X representing position at time 2 seconds. So this is 2 seconds over here. Time 0, 1 second, 2 seconds is -4 meters. The position at 4 seconds, and 4 seconds is occurring over here, is 0 meters. And again, 0 meters doesn't mean no position. 0 is a number that represents a location in space on this axis system. It represents this location in space. And then I took another time at 7 seconds. And at 7 seconds, the object is at a position of 6 meters. There's another number that we can talk about. It's called displacement. Displacement is defined as the change in an object's position. Literally, we use this delta x equals x final minus x initial. So change in position, the change in a quantity is the final number minus the initial number. So if you had 10 markers in your hand, and then you had 8 markers later on, the change in the number of markers would be the final number minus the initial number. So if you had 10 markers in your hand, initially, and then the final case you had 8 markers, 8, the final number you had, minus 10, the initial number you had, 8 minus 10 is equal to -2. That's the change in markers. -2 means you have 2 less markers than you started with, which should make sense. If you had 10 markers and now you have 8 markers, that's 2 less than you began with. Now the negative sign for positions doesn't necessarily mean less. It gives you a sense of if it's to the left side of the 0 or to the right side. But for a quantity, a negative sign could mean less. So if we're going to find the change in the object's position, we should do final position minus initial position. So let's calculate it for these really quick. The change in position from time 0 to time 2. The final position at time 2 is -4 meters. And I'll erase this stuff really quick so we have some space. So -4 meters minus the initial position. So at time 0, that's our first initial position. That's -8 meters. So we have -4 minus -8. That's the same thing as +8. So we actually get a positive number. We get +4 meters. In other words, the position has changed so that you're 4 meters to the right of where you began, which makes sense. From 0 to 2 seconds, you end up here. You started here. So if you look, you are 4 meters to the right of where you began. The information makes sense with the picture, with the qualitative picture. If we find your change in position from 2 to 4 seconds, so now your initial time is 2 seconds, your final time is 4 seconds. So let's go to 4 seconds. This is where the object is at 4 seconds. That position is 0 meters. Minus your initial position. The initial time was 2 seconds, so negative 4 meters. And we'll see that again, we're getting positive 4 meters. So between times 2 and 4 seconds, the object moved another 4 meters to the right, from here to here. And again, that makes sense on the picture. This space is the same as this space. And then if we do from 4 to 7 seconds, which is a bit more time than before, so we might expect, given the nature of this picture, to have the object move further to the right. And we should see that if we go to the position at 7 seconds, we have 6 meters. 6 meters minus the initial position, and here initial means at 4 seconds. Initial doesn't necessarily mean the very beginning. It doesn't necessarily mean time 0. It means the first time that you've decided to study. And for this particular problem, I'm studying 4 seconds as my initial case. So at 4 seconds, the position is 0 meters. 6 minus 0 is a positive 6 meters. And from here to here, the object is indeed 6 meters further to the right than where it was before. Also notice, we talked about distance. The distance traveled from 0 to 2 seconds also happens to be 4 meters. The distance traveled from 2 to 4 seconds. This distance is also 4 meters. The distance traveled from 4 to 7 seconds. This distance is also 6 meters. So right now it might look as if displacement and distance are the same thing, but they are slightly different, and we'll hope to show that in a future slide. What I'm trying to show in this slide is that we've moved the axis system. It's the same motion diagram in the same place, but what if I move my axis system so that my origin is someplace different now? So at 4 seconds, the object isn't at position 0. In fact, position 0 has been moved over here. So at 4 seconds, if this is 1, 2, 3, 4, the object's actually at a position of 3. That's going to change my positions. I'll go through these really quick. Position at 0 time is negative 5 meters. The position at 2 seconds is negative 1 meter. The position at 4 seconds is 3 meters. And the position at 7 seconds is now 9 meters. These are all new positions compared with the previous motion. But it's the same motion. It looks the same. The object's moving to the right in a similar way as it was before. And we should see that when we make these displacement calculations. These should be the same. From 0 to 2, final position minus initial position. So it's negative 1 meters minus 5 meters. And again, that's positive 4 meters. Negative 1 plus, because we have minus a negative, 5 gives me positive 4 meters. From 2 to 4 seconds, 3 meters minus negative 1 meter is also equal to positive 4 meters. From 4 to 7 seconds, we have final minus initial. The final position is 9 meters minus 3 meters is positive 6 meters. And you'll see that these numbers are the same as these numbers were. Just because we moved where the axis system was, just because we literally pick up and move this axis system over, doesn't mean that this motion has changed. Just the numbers that we're using to study the positions have changed. But these displacements have remained the same. So one other thing that we can do is we can use an arrow to represent displacement. And here's a case that's a little bit different than the other ones. Here's time 0 seconds. 1 second, 2 seconds, 3 seconds. I think you'll see this time the object is moving to the left. In the process of moving to the left, our displacement is going to end up being a negative number. And I'm representing that with this arrow that begins at the initial position. I'm studying it at time 0 to time 3. So the initial position will be at time 0. The final position will be at time 3. So the object is traveling from a position of 3 meters to a position of negative 9 meters. The initial position over here is 3 meters. the final position is negative 9 meters. And if I use that the change in position is the final position minus the initial position, I get final position of negative 9 meters minus the initial position of 3 meters, I get negative 12 meters. And if I take a look, the object started here, ended here. It has moved 12 meters to the left from time 0 to 3. And I can use an arrow, this red arrow, to represent that. The red arrow is 12 units long according to this picture, and it points to the left. And notice if I move the axis system like this, the arrow is still 12 units long to the left, from 5 to negative 7, spans 12 units to the left. One last thing, the distance is not negative 12. Distance doesn't have a plus or a minus sign, it's just a path length. So the distance the object traveled is just 12 meters. And here's one of the differences between distance and displacement. Distance just tells you how far you traveled. You've traveled 12 meters from this time to this time. But displacement also has a direction associated with it. Right? Displacement doesn't always tell you how far you traveled. It literally tells you where you are in reference to where you began. If you began here and you ended here, you're 12 to the left from where you started. And that's what displacement tells you. And that's the end of 1-2.